In the study of chemistry, you would have realized or see the pattern that we are basically categorizing substances into different categories and studying the properties of the categories. So, nothing special to organic. Same thing, we also classify them, but we call them the homologous series, means a group, a category. And in each homologous series, it will have the same general formula and functional group. The functional group will determine the type of chemical reactions. That means it determines the chemical properties. And you will see that functional group is a group of atoms that's very special to this homologous series only. So first, let's look at alkane. Alkane, as what we have learned, or we know that mainly are your crude oil, your petrol, your diesel. And let's look at the members of the alkane homologous series. Basically, it ends with the A and E. No, your methane, ethane, propane, butane. By looking at the last few letters of the name, you will know that which homologous series does it belongs to. And another pattern that we can see, or another way of that they will usually name, is they look at number of the first few letters will tell us the number of carbon. Met means 1 carbon, it means 2 carbon, prop means 3 carbon, but means 4 carbons. In short, you will know, you can memorize it like mass, eat, proper, breakfast. Anything that's more than 4, it will be similar to what we have understood in polygon. Like pens means pentagon, 5-sided alkane, 5 carbon, hexane, hexagon, 6-sided. So it's something similar to how we name the polygon, the number of sides. Now, how we get to the molecular formula? We are using the molecular formula based on the general formula, CnH2n plus 2, where N is the number of carbon. So for example, methane, you will sub N equal to 1 and you will get CH4. Same thing, for ethane, you will sub N equal to 2, you get C2H6. Similar, propane, N equal to 3, you will get C3H8. And your butane, you sub N equal to 4, you will get your C4H10. You just sub N into the general formula. And you can also see a pattern. If they are members of the same homologous series, there will be a difference of CH2. The difference between one after another member in the same homologous series will be by a difference of CH2. Last, let's look at the structure formula. We know that the functional group alkane are known as saturated. Saturated means they are basically only contain single carbon bond. And they are called hydrocarbon because you will see that they are only made of hydrogen and carbon, all of them. So how do we draw structure formula? Just follow the 3 steps. First, number of carbon. Second step, functional group. Last step, every carbon has 4 bonds. For the methane, okay, I will draw 1 carbon first. Then, since every carbon must have 4 bonds, every carbon must have 4 bonds because carbon is in group 4. It has 4 valence electrons and needed 4 more electrons to be stable. That's why you form 4 bonds. Ethane, I'll draw 2 carbon first. For example, I'll show you, okay, 2 carbon first. Okay, definitely must be bonded. Then this carbon only has 1 bond here, so it will need 3 more. That means it needs 3 hydrogen. Similarly, this carbon has 1 bond, it will need 3 more to make it 4. So you put in the hydrogen. And this will correspond to the molecular formula of C2H6. 2 carbon and 6 hydrogen. The line just represents a single bond. That means a pair of electrons shared. Similarly, we do the same thing for propane. 3 carbon, and then we can count and make sure every carbon has 4 bonds. And the structure formula should correspond to the molecular formula C3H8. C3H8. And this will continue for butane.